Hello?
We can hear you, yeah. Okay, please start your presentation.
Okay, Lashir,
Okay.
I want to continue.
Okay, yeah.
Hello guys, I'm Conrad. Today my topic is control of generation. For my topic, the outline are automatic generation control, and purpose are an overview of automatic generation control for single generator and double generator, also for multi-generator. And now come to the purpose of automatic generation control. The purpose is to maintain power balance in the system and make sure the operating limits are not exceed the generator limits and tie lines limit, and make sure that frequency of the system should be constant. It means no change with the change of load. Now come to the overview of AGC. So first of all, load is always changing. As we know, load is always changing, and to maintain power balance, generator need to produce more or less to keep up with the load. Means when generation is less than load, then automatically generator speed and frequency will drop, and vice versa. For generation is greater than load, then generator speed and frequency will rise. So now come to the component of AGC. So there are three components: primary control, secondary control, and economic dispatch. So now come to the primary control. So immediate automatic action to sudden change of load. For example, the reaction of frequency change. So this is the example of primary control. Now come to the secondary control. To bring trial line flow to schedule, corrective actions are done by operators. So and now come economic dispatch. So make sure that units are scheduled in most of economic way. So now for the multi-generators, we consider effect of the power flows in the transmission lines, and also the load at each bus to mechanical power of each generator. So this analysis assumes that every bus is generator bus. So for the multi areas, simplified control model and area control error. So the simplified control model, the generators are grouped into control areas. Now consider the following bullet points. An area is one generator is single area. So tie lines between areas are transmission line connecting buses in single areas. So we can apply the same analysis to multi-area. However, we have to come up with characteristics of each area. Basically, actual application of this model is for powerful operation. So for the powerful operation, get a few points elaborate here. So power operation pool is an interconnection of power system individual and same system frequency. The system frequency should be same. For the power pool operation, the basic rules are the following: to maintain scheduled tie line capacities, and each area absorb its own load changes. So now come to the multi areas for means AGC for multi areas. So the multi areas during the transient period, sudden change of load causes each area generation to react according to its frequency characteristics. This is called primary control. Of course, when the load is changes, means transient period is changes, in the transient period, the load automatically sudden change in the generation, and this is called primary control. So this change will affect a steady state frequency. Of course, the load automatic sudden change of load, the frequency will be affected. So steady state of frequency and tie line flows between areas. So we need to restore the system frequency and restore the tie line capacity to the scheduled value, and make sure that they absorb their own load. So this is the portion of secondary control. So trial and bias control use SE to adjust setting control power to each area. So for the trial and base control, so following our goals to drive AC in all area to be 0 and to send appropriate signal to setting control power, and use integrator controller so that AC goes to 0 at a steady state. The following are implementation for AGC. The AGC schemes are usually centrally located at a control center, and system measurements taken at the major substation, other information and data are telemetry to the control center. And control action are determined in a digital computers. I mean, so we can collect all the data or determine the control action in the digital computers. And digital signals are transmitted to the generation units at remote generation station over the SAM communications channels. So raise and lower power pulse signal change in the generation units, load reference point up or down. So for the calculation of AGC, the control must also drive the generation units to obey the economic dispatch, in addition to pushing the frequency and type flow error to 0. The sum of the units output errors is added to the AC to form a composite error signal. And the generation allocation calculation is placed between ACE and the governor central unit control loop. So for good design requirement ACG means for the good design of ACG, we should keep in mind the following points. The AC signal should be kept moderate in size, means the size of AC signal should be moderate. And ACE is influenced by random load variation. The standard deviation of ACE should be small. And the ACE should not be allowed to drift, means the integral of ACE should span an appropriate but small time period. Drift has a effect of creating system time error and inadvertent interchange errors. And finally, the control action should be kept in minimum. Many errors are simple random load changes that should not cause any control action. Changing these random variation only wears out the unit's speed, changing hardware. So this is the my presentation. Now remaining topic will continue my colleague, and he will share with you.
Ella, do you hear me?
You please stop the screen sharing and then open again and then share again.
You can click on the here, the
Change the
toolbar.
tab.
You need lecture 13.
Where?
Please
You close
stop the screen sharing and then reshare again.
I can stop and share again.
Yeah. Stop
First-
it. Just close it and open again.
But first you close the PDF file, then you will see the VooV Meeting. Please close the PDF file and now open the, okay.
Okay.
I think.
It's okay now.
Hello everyone.
Hello.
I'm going to present generation control. So first, what is automatic generation control? What is it? It is the major control with utilities, energy control center, center control function with utilities, energy control center whose purpose is tracking of load variation while maintaining system frequency and need tie line interchange and optimal generation levels close to specified vary actually automatic generation control, it has the three major objectives. First one is hold the system frequency at specified normal value, example 16 Hz. And the second one, to maintain the correct value of interchange between control areas. And upfront contract for shipping or receiving power along the tie lines to neighboring authorities, and maintain each generating unity operating point at the most economic value. And here we are going to see the supplementary control action. Supplementary control action assume for the moment that a single generating unity supplies load to an isolated power system. A load change will produce a frequency change. Magnitude depends on the drop characteristic on the governor and the frequency characteristics on the system load. The supplementary control must act to restore the frequency to the nominal value. A compressed draft and integral control loop to the governor. The control action forces the frequency error to 0 by adjusting the speed reference set point. Here, in order to understand this supplementary control action, here I have a screenshot. Sorry. Supplementary control. A generation control, supplementary control action is act to restore frequency. Here we have governor and prime mover, and frequency restore control, and rotating mass and frequency depend on the load. A governor, each unity maintain its speed, while supplementary control, usually originating at remote control center, act to allocate generation. This is generator loading set point, and this is speed frequency drop control, and rotating mass and frequency depend on the load. Here we have tie line control. What is tie line control? Tie line is an interconnection. Tie line control. Two utility with interconnected the system for several reasons by and sell power with neighboring system whose operating costs make the transaction profitable. Improvement to overall reliability for events like this sudden loss of generating unity. Provide a common frequency reference for frequency restoration. And